Okay, in this video we're looking at dot products, or they're sometimes called scalar products. It's basically a way to take two vectors and times them together, sort of. It spits out a number as your answer. So let's just do an example of this. We've got these two vectors P and Q, and essentially what we're trying to find is P, so 2, 3, dotted with 1, 4. That's our goal. So we'll see if we can do that. Basically all you do is you times the top numbers, so that's 2 times 1. Plus, and then you times the bottom numbers, 3 times 4. So you're going to get 2 plus 12 and 14. I hope we can agree that spits out a number, not a vector. In year 12, we're going to learn a different kind of vector timesing, which does spit out a vector, but that's a long way down the road. Okay, so here we've got this vector, 5, 3 dotted with 2, 1. And you're basically going to do 5 times 2. So that's going to give you 5 times 2 plus 3 times 1. Which I believe is 10 plus 3, which is 13. Next one here, I've got this situation. So if I've dotted these two vectors, I'm going to get 7. I want to find k. So the dot is going to equal minus 3 plus 5k. And that's all supposed to equal 7. So that's minus 1 times 3 gives you minus 3 and 5 times k. Then we're going to add 3 to both sides. So 5k equals 10, and then k equals 10 over 5. Last thing we're going to do with this is prove the first algebraic property of dot products. I've got it up here in the topic booklet. I think it's v dot w equals w dot v. So v dot w equals w dot v, and this is kind of like our want to show. So we're going to say let v equal, I should have lines under all these vectors. V should be v1, v2, and w equals w1, w2, where all these numbers are just real numbers. Okay, great. So if we look at v dot w, that's going to be a number. It's going to be v1 w1 plus v2 w2. So when you times them together and add them, and if you look at wv, it's going to be w1 v1 plus w2 v2, which you can simplify down v1 w1 because it doesn't matter what order you times two numbers in, you get the same result. Thing like 3 times 4 is the same as 4 times 3, and then here v2 w2. Which matches, hopefully. Therefore, we've done it. v dot w equals w dot v for all vectors v and w. So that's how you prove something like that. And it's kind of weird because it feels like you're doing something wrong with how simple it is, but it's one of the very simple proofs. It's just proving that these two things are commutative. That means it doesn't matter what order you times them in.